classes on fundamentals of electrical circuits. We are moving into power measurement. Okay, essentially AC power measurement, because DC power measurement is very simple. Simply multiplication of the voltage and the current is sufficient. So we'll be doing mostly AC power measurement here. Okay, and some of the basics are being covered now. Okay, like for this is an area wherein quite a lot of doubts are there. So that's the reason why I'm trying to make some comments which will be following through via the problems. Okay. Actually, the voltage and current directions decide the active power absorption or delivery. Like for instance, if both the voltage and current directions happen to be the same at a point of time. Okay? Let's say at t equal to a particular time, then we say that the current is there is generation of power. On the other hand, if they are in opposite direction, then there is absorption of power, or that element is taking in power. Okay, yeah. So that's one point. Okay. Second is, of course, regarding the leading or lagging part of the current. Okay. So if the leading and lagging part of the current with respect to voltage needs to be found out, it's not easy to find it out directly unless, of course, they are in the same quadrant. Okay. So they are reflected back into the same current. Okay. One of them is reflected back to find out such that both voltage and current phases happen to be in the same quadrant, and then it is seen, then you go in the anti-clockwise direction to see what is leading. Okay, so if you go in the clockwise direction, and what you encounter first, if it is voltage, then you say that the current lags, and then so it's actually absorbing reactive power. Okay, because it indicates an inductor. On the other hand, if you are as you go in the clockwise direction, okay, so long as they are the same quadrant, and then you see the current phasor first, then we see that the current is leading, and this actually happens with respect to a capacitive circuit, and so it is delivering reactive power. Okay, so this aspect also needs to be remembered appropriately. Okay. Third is, of course, something that we have been doing several times. That is, whenever there is whenever there is a maximum power to be absorbed by a resistor, then Thevenin's equivalent is taken, and that gives rise to the power equation. Okay, moving on to So as I said earlier, when you have to actually bring both the voltage and the current in the same quadrant, and thereafter go in the clockwise direction. Okay, and see what comes first. Okay, what comes first is supposed to be the leading quantity. Okay? So let's start. Let's do some problems. So let's do the first problem, where in this case mostly you'll get statement kind of problems. Okay, a single phase load is supplied by a single phase voltage source. Okay, if the current flowing from the load to the source is 10 angle minus 150 degrees. Okay, so I have tried to draw a figure to show the current which is at minus 150 degrees, which means that you go in the clockwise direction and mark out current with such that it is minus 150 degrees with respect to the original horizontal axis, which occurs at 0 degrees. Okay, if the voltage at the load terminals is 100 angle 60, so the voltage terminal now the voltage is now shown as equal to having a positive 60 degrees. So you go in the anti-clockwise direction because angles are positive in the anti-clockwise direction, and you mark out V. Okay, so when we realize that now with respect to the horizontal, the current is at 30 degrees. Okay, and so as I said earlier, you project it back such that you can now talk about the leading or the lagging concept. Okay, so obviously, since voltage and current are in opposite directions here, we have what is called as an absorption of power. Okay, so absorption of power is okay, and so either answer A or B are right. Okay, so it is absorbing power, it's not a generating element. Now we move on to observing whether the voltage is leading or the current is leading. So you go in the clockwise direction. So you see that you encounter the voltage first, after of course reflecting the current back such that they are the same quadrant. Okay, so now which means that the current is lagging, and this happens for an inductive circuit. So it is absorbing again reactive power as well. Okay? So answer B is right. Okay. So similarly, question number 2, where voltage is given as V cos 100 pi t, has the internal impedance of 4 plus J3 ohms. Okay, if a purely resistive load, so a source is there, it has an internal impedance 4 plus J3, so it's which is equal to a 5 ohm with an angle. Okay, if a purely resistive load connected to the source has to extract the maximum power. Okay, so if it's a purely resistive load, you can't add 4 ohms there. You have to add a 5 ohm resistor. Okay, so 4 square plus 3 square, square root of it is gives you. So the resistor is going to be 5 ohms. Okay, and then so what's going to be the maximum power out of it? That so yeah, this has to extract the maximum power out of the source. Its value in ohms has to be, as was mentioned earlier, 5 ohms. Okay. Just a repeat of what we said earlier. Okay. Moving on to the third problem. The voltage phasor of a circuit is 10 angle 15 degrees and the current phasor is 2 angle minus 45 degrees. Okay. So I suppose by now we have started seeing things like, for instance, 10 angle 15 degrees is 15 degrees with respect to the horizontal, and 2 angle minus 45 degrees is going back or going in the clockwise direction 45 degrees. So total angle is going to be 45 plus 15, 16 degrees. Okay. The active and reactive powers in the circuit are. So active power is very simple. These are RMS values. So that's 10 into 2, okay, into cos 60. So 10 into 2 into half, that gives you 10 watt. Okay, now and from the 4 answers, it's very clear that only answer A has 10 watt. Okay, all the others are B 5 watt, 20 watt, 20 rotor. So you can immediately say that this is A is going to be the option that you have to choose. But at the same time, just let us have it look at the reactive power. If cos 60 is giving you 1 by 2 as is 1 by 2, then sine 60 is going to be root 3 by 2. So 10 into 2 into root 3 by 2, so that is again equal to 17.32 as the volt ampere reactive. Okay. Moving on to problem 5, when a resistor R is connected to a current source, it consumes a power of 18 watt. Okay. So there's a resistor and it consumes a power of 18 watt. Okay. And the source is a current source. So I square R is equal to 18. Okay. When the same resistor R, okay, is connected to a voltage source having the same magnitude. So again, V square by R, where V is the same as equal to I. Okay, so I square by R is equal to the power absorbed by the resistor is 4.5. So now we have two equations. One is I square R is equal to 18 watt and voltage V square by R, where V is the same as equal to I. So I square by R is equal to 4.5. The magnitude of the current source and the value of the resistance. It's easier to find out the value of the resistance first. Okay, because I square R divided by I square by R gives you R square as equal to 18 by 4.5, which is equal to 4. Okay, so R square is equal to 4 or R is equal to 2, and there's only one answer there, and that's equal to 2. Okay, as it is, you can just check out 3 3 the 9, that is I square into R is equal to 18. Okay. So the problems in this section are very simple. Let me hope that you have understood appropriately. Okay. So let me go for the fifth problem. We have a diagram there. There's a 6 volt DC source. There's a 1 ohm resistor there, and then there is an unknown impedance or whatsoever which through which current I flows. Okay. Yeah, so let's read the circuit shown in figure. X is an element which always absorbs power. Okay, during a particular operation, it sets up a current of 1 ampere. Okay, so I is equal to 1 ampere at a particular point of operation. Okay, in the direction shown, and absorbs a power Px. Okay, so what is Px? That should be our first understanding. That should be our first goal. Okay, it is possible that X can absorb the same power Px for another current I. And what is this value of this current? Okay, so if so first let us find out Px, because Px remains constant through both the operations. Okay, one is when we are having 1 ampere, and other is when we are having I ampere. So when we are having 1 ampere, it's very clear that the power released by the 6 volt source is equal to 6 into 1. Okay, 6 watt is given, of which 1 watt is absorbed by the 1 ohm resistor, because 1 square, which is okay, 1 square into 1. So 6 minus, so 5 is equal to 6 into 1 minus 1 square into 1. Okay, so it is detailed on the side. And now the same power, same power Px, which is equal to 5 watts now, is now going to be delivered to the source through another current I. Okay, so what is Px right now? It is the same as equal to 6 into I. Okay, that's the power gets generated, and then I square into 1 is taken out of it, and then the resultant is going to be the same px, which is equal to 5. Okay, just solve it out. It's very, or else just substitute. Okay, when you substitute 5 ohms, you get 5 ampere, you can see that the answer is correct. Okay, 3 minus root 14, 3 plus root 14 are actually uh, perhaps given to confuse you. Okay, so the better answer is 5, because you see that 6i minus I square is equal to 5. Okay, so if you just substitute for I as equal to 5, so 65 to 30, and then I square is equal to 25, so 30 minus 25 is equal to 5. You can easily do that. Okay, moving on to the sixth problem. A water boiler at home is switched on to the AC main supplying power at 230 volt 50 hertz. The frequency of instantaneous power consumed by the boiler is, okay. Anytime the power in a circuit is called as, okay. Of course, power in a circuit is related only to the only to the to a resistive element. In all other cases, it's not going to be. It's not going to be. It's going to be zero. But for a resistive element, it's going to be a double frequency situation, as is shown in the diagram. Okay. But of course, the waveform is of a different shape. It's not purely sinusoidal, but it is double frequency. Okay, and so we immediately go to the answer as equal to 100 hertz. So today, today in this session, and that is the first session in power measurement, the focus was on the fact that there are two situations that come out immediately. That is, there is active power and reactive power. Okay? Active power is positive whenever the voltage and current, or the active power is being absorbed whenever the current and voltage are in opposite direction. On the other hand, when they are in the same direction, power is being generated. Okay? So it is being delivered. Okay? Reactive power is positive whenever we are having a capacitance in the situation. Okay, or in other words, current should lead the voltage, whatever. Okay, and they should be in the same quadrant. Only then you can realize whether the current is leading or not. Okay, on the other hand, reactive power is being absorbed whenever the whole circuit is mostly inductive. Okay, if it is inductive, then the current has to lag. Okay, how do you see if the voltage of if the current is lagging or leading? In that case, you just project either one of them, the voltage or the current, such that they happen, both the voltage and the current happen to be in the same quadrant. Then you go clockwise and see which one you encounter first. Whatever you encounter first is going to be the leader. Okay, and so based on that, you can draw your conclusions. Okay, so I suppose this session is very simple, and we'll go on to the second session. Thank you.